All right, this video is going to introduce the idea of function notation. Function notation. And in order to talk about function notation, we should talk quickly about, again, what was a function? We've studied these before. Remember, a relation is relating inputs to outputs. And a relation is a function if every input has exactly one output, such as the function we have in this mapping diagram here. Every number of the input, right, 1, 2, 3, 4, goes exactly one place. Now notice 2 and 3 both go to 4, but that's okay. 2 goes to 4, that one input has one output. 3 goes to 4, that one input has one output. Again, every input has exactly one output. And the domain, remember, are the inputs. The output list would be the list of the range, right? All the numbers we could get back. So think about sort of an XY coordinate, right? The X's would be the inputs, the Y's would be the outputs, the list of X's would be the domain, and the list of all the possible Y's would be the range. This function down here, or relation I should say down here at the bottom, is not a function because again, notice that 1 goes to both 5 and 7. I don't want to plug in X as 1 and get back two separate numbers. Now, on a graph that's represented very quickly and simply, if a graph doesn't pass the vertical line test, right? If I can draw a vertical line that crosses in more than one place, so notice the graph at the right, my vertical line, that red line is crossing in multiple places, right? On my axis, crossing both at the top and at the bottom. Therefore, that's not a function. Whereas no matter where I would draw the vertical line on the graph at the left, it would only cross in one place. Therefore, that is a function, right? Every x value only has exactly one y value. Now, function notation, on the other hand, a kind of a little bit of a switch, is basically just saying, well, instead of saying y for the output, we're going to call it f of x. So the first thing I want to do is write something in function notation. I want to solve for y. So notice over here at the left, I'm going to add 2x to both sides and basically get the fact that 2x minus 3 would be what my equation would look like. And we call that sometimes function form, right? Y equals 2x minus 3. So that I can plug in x and find y very simply. Well, instead of calling it y, why don't we just call it f of x? F is going to be all the outputs, kind of like y was, at the points where x, exists, right? Another way to think of that is the question down here at the bottom, evaluate when x equals 2, can be reworded as saying find f of 2, right? Instead of f of x, let's find f of 2. So our equation up top, remember, was 2 times x minus 3. And what I would do is just insert my x value, right? Instead of x, I'm going to insert the fact that x is 2 in this problem. So 2 times 2 would be 4, minus 3 is 1. And I could plot the point, right? The input was 2, the output was 1. The point 2, 1 is definitely going to be on my graph, right? The point 2, 1, right, will be a coordinate on my graph. Now, we could also take advantage of the fact that we know this looks a whole lot like y equals mx plus b, and we could get lots of other points, right? That 2 would be our slope, and that negative 3 would have been our y-intercept, so negative 3 with a slope of 2, right? Or essentially 2 over 1. So we would go up 2, right 1, up 2, right 1. Notice taking us right through 2, 1 there. Up 2, right 1, up 2, right 1. Or we can go down 2 and left 1. Down 2 and left 1. So I could, again, get a point down there. The more points we have, the easier it is to draw a nice straight line. And again, we've got that thing graphed. I even have a coordinate labeled. I'll still label my axis and say I counted by ones. Again, more importantly would be that function notation, though. F of 0 is saying 2 times x minus 3. But again, take out x, call it 0, right? That's f of 0, not f of x. So 2 times 0 is 0, minus 3 is negative 3. And notice we would have had the point 0, negative 3 on our graph. And the same thing goes. 2 times negative 3 is negative 6. Minus 3 again from our equation. So negative 6 minus 3 would be negative 9. Okay, you can double check those numbers. Can't see that one on our graph, but again, we could find lots of points in function notation. Well, let's do that a couple more times. We've got a function here on this page. Feel free to pause the video. I'm going to just start filling it in and say that f of x minus 7, again, that's my function, right? But I'm going to take out x because I want to plug in all of those x values. Instead of x in this first problem, we're finding f of -3. Instead of x in the second problem, we're finding f of 0. And again, instead of f of x here, right, f of x has been replaced by 5 on both the left and the right. So again, 4 times -3 is -12, minus 7 is -19. And I could rewrite my answer if I wanted. F of -3 then equals -19. Now you might be tempted to divide because that looks like multiplication, but it's not. Remember, this is function notation. So we're saying f would be the machine. When we insert -3, like putting quarters in a machine, we get back -19, right? Like getting back our prize or our pop or our candy or whatever it might be from that machine. We input the x into the machine and get back the output. Again, this one's going to come out to -7 if you check your numbers, and 20 minus 7 would be 13. So we get our answers there. Now we could reverse the question just a little bit if we want to find the value of x so that the function has a value of 33, right? Very simply, well, find the value of x so that our function has a value of 33 means that on the left, we're going to be equal to 33. But on the right, it's still our function, right? Find x. We don't know x. So again, I would quickly add 7 on both sides, saying 40 equals 4x. Since we're multiplying 4 times x, I'm going to divide away that 4. And basically 10 equals x would be my answer. Right? I was looking for x. I found x. So x equals 10. Again, another way of writing that, though not a great way of expressing that we found x. So again, x equals 10 is the best way to write this. But what we basically found was that f of 10 would have come out to 33, right? That's basically what they're saying. But again, the answer, the best possible answer is just stating what is x. Find the value of x. Well, we did. Find the value of x, so we did. Now, hopefully that helps you, again, with function notation. If you want to see how it applies to the real world or how it would apply to an application problem, again, this is video 1 of 2, so feel free to watch the second video. If you have any questions, make sure you talk to your teacher. Good luck and have fun.